Okay, hi everyone. This is Group U9's presentation. My name is Alexis.
My name is Prab.
And my name is Taehyun.
And we're going to be speaking about the shortage of semiconductors. So this started back during the COVID-19 pandemic. The factors that have contributed to this are the virus outbreak, challenges in labor, and geopolitical uncertainties. The pandemic led to a significant increase in demand and a supply that could not keep up with this demand. This is because the pandemic created a need for more and better technology to allow people to work virtually from home. Unfortunately, we have seen in South Asia how downstream operations have been negatively affected by the COVID-19 and has created more of a bottleneck in the supply chain. And this affects the back-end operations in Malaysia, where they perform most chip packaging and testing, which is more labor-intensive than the wafer fabrication process, which is basically a process of producing photonic and electric circuits to build components with required electrical structures. So for this slide, I'm just going to get into a little bit more detail on semiconductors or chips, why they're important, and the general effects. So firstly, semiconductor chips can be found in thousands of products that we use on a daily basis. This includes smartphones, computers, appliances, medical equipment, and even modern day vehicles. They lie between the conductor and the insulator to control the flow of electric current in electrical equipment. We would not be as nearly as advanced as we are today without them. And many industries benefit from the semiconductor industry since it helps power technology and allow for technological advancements. This makes it them important as we wouldn't have many of the advancements that help us day to day. And the most affected industries due to the semiconductor shortage are the automobile industry and personal electronics industry. Personal electronics account for roughly 50% of global chip consumption, while cars account for about 15%. However, cars have been the most affected during the pandemic. Differing on levels of connectivity, an average car can use over 100 chips on board and requires thousands of them for things like safety features, electrical and powertrain systems, connectivity, and more. These are important to ensure the safety and effectiveness of automotive technology, since at the start of the pandemic, the need was for more personal electronics in vehicles due to switching to virtual workspaces. More semiconductors were allocated toward that industry. Near the end of 2022, the demand for vehicles had increased due to low interest rates and more expendable income of consumers. So by spring of 2021, factories were forced to cut production and temporarily close due to disruptions in parts. The shortages also drives up the price of newer cars, and they were hitting record highs in 2021 and 2022 due to supply constraints and drop in demand caused by inflation and increased interest rates. The automotive industry also has to keep up with the need for more electric cars, and electric cars use more semiconductors than an average car. So the need for chips continues to increase for this industry. Ultimately, the automobile industry is dealing with unmet demands due to the shortage, which leads to ineffectively meeting customer needs and can lead to a decrease in revenue. Similarly, dealing with bottlenecks in the supply chain can impact the flow of manufacturing, increasing time and expense of production.
In this slide, we'll see why suppliers were unable to meet the demand. Manufacturing semiconductors requires massive silicon fabrication plants that need billions to fund and use huge amount of water and energy. Water is the most important resource in making semiconductors. Chips are built by adding different layers onto a base silicon wafer, and after each layer is added, it has to be cleaned extensively using high volumes of ultra-pure water, which is thousands of times cleaner than normal drinking water. A typical chip company makes about 2 million integrated circuits per month, and at the end waste about 20 million gallons of water. TSMC, which is Taiwanese company, alone used 5% of all of Taiwan's electricity and used about 63 million tons of water. However, Taiwan's worst drought in 56 years in 2021 caused a reduction in water and energy use. According to BBC News, many of Taiwanese reservoirs are at less than 20% capacity, with water levels at some falling below 10%. Struggling to ensure supplies of chips, the Taiwanese government stopped irrigating more than 74,000 hectares of farmland in 2020. Taiwan also turned off the tap water for residents and businesses in 3 cities and counties, including one of its biggest municipalities, Taichung, 2 days a week. However, it was not enough to secure water for all of the people in Taiwan, so in dry areas, high-volume industrial users, including semiconductor manufacturers, have been asked to reduce water usage by 13%. One of the primary water sources for Taiwan's $100 billion semiconductor industry, the water level was at the lowest it's ever been, which was only 7% full. Clean water is essential, as it is mentioned, to the production of semiconductors, but due to the drought, the amount of clean water decreased, resulting in a drop in semiconductor production. This was the problem because around 90% of the most advanced microchips were manufactured in Taiwan. Another cause of shortage is the Texas power outage in 2021. This resulted in many semiconductor fabrication plants behind on their production goals. Next is about political conflict. While Korea was one of the top chips manufacturers, Japan restricted exports to South Korea of the 3 chemicals that are essential for making semiconductors in 2019. This resulted in lowering the production of chips. Another factor that is believed to have boosted demand and caused the supply shortage is Bitcoin. Bitcoin is an open-source, decentralized payment system that operates in a peer-to-peer environment. It doesn't need bank or central authority. Bitcoin is one type of cryptocurrencies, which is a digital asset where a secure form of mathematics is used to handle transactions. It is controlled the creation of additional units and verify the transfer of assets. Now let's see how it works. Bitcoins are transferred from person to person like cash. Transactions are recorded in a distributed decentralized public ledger known as a blockchain. Verification and timestamping of transaction is performed by a pool of users called miners. No one can transfer the asset without the special password called a private key, usually stored in a cryptocurrency wallet, which is really just an encrypted holding place. Passwords are virtually impossible to guess, and verification makes sure no one spends the same Bitcoin in 2 places at once. Right now, most cryptocurrencies rely on massive amount of computing power for the competition that determines which stakeholders acquire more tokens. In other words, greater computing power necessitates more semiconductors. Because of the benefits of bitcoins, such as no transaction fees and high privacy, people tried to earn as many bitcoins as possible. Bitcoin had a price of around $7,000 on December 31, 2019, and a year later it had appreciated more than 300% to $28,984. It continued to surge in the first half of 2021, trading a record high of $68,990 in November 2021. So in 2018, cryptocurrency represented a significant portion of the market share for semiconductor manufacturers. For example, crypto-related buyers represented roughly 10% of Taiwan semiconductor sale. Next is labor shortage. To be precise, skill shortage in the industry. The semiconductor skill shortage is not a new thing since a 2017 study reported that 77% of United States semiconductor manufacturers thought there was a talent deficit within the industry. They also They also anticipated it would get worse, leading to a peak in 2020. Although only 20% of semiconductor workers don't hold a university degree, it is because creating these chips requires skilled workers to do the job and special training. But companies couldn't fully achieve to have workers to have appropriate skill, resulting in long lead time in a time of huge demand. Shipping delays also increased the long lead time. David Levi, a professor of MIT, and Matthew Loy, a North America purchasing manager, suggests several possible solutions to solve the chip shortage in the States. Although expanding the number of semiconductor fabrication facilities in the States is the obvious solution, the first solution they suggest is to increase the resiliency. They suggest by having both domestic and international facilities, the states could increase resiliency. The second suggestion is to focus on different types of chips. Before the shortage, the industries were focusing mainly on advanced chips. However, by ensuring the supply of older generation chips, the industries such as automotive and aerospace, as well as the military, wouldn't experience chip shortage as in the pandemic. Because all chip technology nodes are responsible for the majority of the chips used by the automotive industry. The third solution is fashioning a short-term response. They anticipated that constructing a new semiconductor facilities would take more than 2 years. During that time, they suggest the government to ensure chip supplies by building a chip reserve capacity, encouraging original equipment manufacturers and the suppliers to reuse chips, and developing IT tools for people to check amount of inventories that are available. Thank you for listening, and these are the questions. And here's the works cited. Thank you for listening.